Students, start करेंगे our discussion of the amplitude shift keying और ASK. Students, दो चीजें मैंने आपको introduction में बताई थी. The first one was that first technique out of the four of converting digital data to analog signal is amplitude shift keying or ASK. And students, number two is about a carrier signal. So in this case, we have got a carrier analog signal that is a high frequency signal that's produced by the sending device. Students, ASK या amplitude shift keying में we vary the amplitude of this carrier signal and we use this carrier signal to as a base of our information that we are going to be carrying. Students, amplitude is varied, but frequency and phase, they remain constant in ASK. And students, the most common ASK technique that is based on two levels, 0 and 1, is called binary ASK, or it is called OOK or on-off keying. Let's go to the slide and let's try to understand that further. On the slide, as I've told you, ASK is normally implemented using only two levels, 0 and 1. Students, binary that's the reason we called this as binary, two levels. And students, in this case, the peak amplitude of one signal level is 0, and the amplitude of the other signal level is the same as the amplitude of the carrier frequency. This is the amplitude that we are talking about. So this, for one, that is our one signal element, we are using the same amplitude as the carrier frequency. And for the other signal element, which is a 0 in this case, as you can see, the peak amplitude to send a binary 0 is 0. Students, our bit rate is 5. So we have got 5 signal elements representing 5 bits in this case. And you can also see that the resulting signal, we have got a carrier frequency down here, FC. And the resulting signal, this is a very interesting fact, the resulting signal is only one simple sine wave, which is produced as a process of modulation, and this is our non-periodic composite signal. So when we do the modulation, the result is a non-periodic composite signal. Combination of sine waves. Students, in this case, the bandwidth is proportional to our signal rate. हम लोगों ने पढ़ा था कि FSK के other than the FSK, for every single technology, our bandwidth is directly proportional to the signal rate. So the same is the case here. Students, bandwidth के अंदर, there is an additional factor that we need to discuss, and that factor, which is involved in this case, is D. Students, this factor D, it depends on the modulation and the filtering process. Students, the value of this D, it will be between 0 and 1, always. Which essentially means that the required bandwidth, it has a minimum value of S and it has a maximum value of 2S. The minimum value will occur when this D is equal to 0. You will get your minimum value of bandwidth. When this D is equal to 1, you will have your maximum value of bandwidth. Students, as you can see, the most important advantage of this digital to analog conversion technique is that we can shift the resulting bandwidth to match what is available.